Okay, we just started talking about ratios and proportions, and now we're going to talk about ratios and polygons, because that's what's going to make it more of a geometry thing than just the algebra part that we've been doing. The first thing we need to know is what the word similar means, and recognize this little symbol here. It's kind of like the top of a congruent symbol, but without the equal sign. And so similar figures have the same shape, but not the same size. So if you look down in this box in the middle of the page, we have two similar polygons. So here we have polygon ABCD and EFGH. And we have this little symbol in between them that tells us they're similar. And remember how the order of the letters mattered? Well, it still matters here. It tells us that AB is similar to EF. CD similar to GH, and all the corresponding sides match up. So in fact, two polygons are similar if and only if their corresponding angles are congruent and their corresponding sides are proportional. Okay, so what that means for you, if you have two similar polygons, we would say that angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G. And angle D is congruent to angle H. So I'm matching up all the angles with their corresponding angle in the other polygon. But now what's really important is the proportional part. So segment AB over segment EF is equal to segment BC over segment FG, and that's equal to segment CD over GH, and that's equal to the last one, which would be AD over EH. And if you weren't sure where those letters were coming from, I'm doing AB over EF. And you see how that's 6 over 12? Well, then if these two polygons are similar, all the sides have to be proportional. So BC is 5.4 over FG, which is 10.8. And you can probably pretty easily see that both of those are equal to a half. And so then CD is 4 over GH is 8. And AD is 5 over EH, which is 10. And all of that equals 1/2. So they're proportional. And we have to write a similarity statement. We'll say that A, B, C, D is similar to E, F, G, H. And that's our similarity statement. Remember, we had congruent statements, so this is a similarity statement. And just like with congruent statements, the order matters. You can't just write all four letters in any order you want. So take a look down here. Example 1. If triangle FGH is similar to triangle JKL, list all pairs of congruent angles and write a proportion that relates the corresponding sides. Okay, so congruent angles. Angle F is congruent to angle J. I know that because F and J are in the same place in the similarity statement. Angle G is congruent to angle K, and angle H is congruent to angle L. So that was the easy part. List the congruent angles. That's not a big deal. Now write a proportion that relates the corresponding sides. So I'm going to follow right along the similarity statement. So FG, let's redo it. Let's do FG over JK equals GH over KL, and that's equal to FH over JL. So there's my proportion that relates the corresponding sides. Okay, the ratio of the lengths of the corresponding sides of two similar polygons is called the scale factor. This is a tricky one, so make sure you're paying attention. Scale factor depends on the order of comparison. So So again, it's the ratio of the lengths of the corresponding sides of two similar polygons. So in the diagram, we have triangle ABC is similar to triangle XYZ. That means the sides are proportional and the angles are congruent. So find the scale factor of ABC to XYZ. Well, that means it's triangle ABC to triangle XYZ. Now, since they're proportional, since they're similar, we know that their side lengths are proportional. So this triangle over ABC over XYZ, we can write 6 over 3 because 6 comes from the AB and 3 comes from the XY, which matches up to our statement. 6 over 3 is 2. So the scale factor is 2, and that just says that triangle ABC is 2 times bigger than triangle XYZ. But if we say find the scale factor of XYZ to triangle ABC, well, that means we're going to take the 3 on top, 3 over 6, and that's 1/2. And that tells us that triangle XYZ is 1/2 of triangle ABC. So it's not a big deal, but it's important that you can get the order right and say when something's twice as big or something's half as big. So determine whether the triangles are shown. If so, write a similarity statement and find the scale factor. So determine whether the triangles shown are similar. Well, requirements are the angles have to be congruent and the sides have to be proportional, right? So angles are congruent. That one and that one, that one and that one. And our third angles theorem tells us that if 2 angles of a triangle are congruent, then the third set of angles has to be congruent. So angles are congruent. Check. Now, are the sides proportional? Well, we got to match them up. Let's see, from the 1 tick mark to the 2 tick marks, and the 1 tick mark to the 2 tick marks. So that is 10 over 12.5. Our next side from the 2 tick marks to the 3 is 9.2 over 11.5. And then our last one from the 3 back to the 1 is 12 over 15, right? And notice I decided to put the 10 on top here to start with. Doesn't matter which way you do it, but I'd pick that way. Once I put the 10 on top, notice that the 9.2 is on top, the 12 is on top. This smaller triangle is going to stay on top. Now, these numbers right here aren't typical fractions like you're used to, but that's okay. We can just divide them out with the calculator. So 10 over 12.5 equals 0.8. 9.2 over 11.5 equals 0.8. And 12 over 15 equals 0.8. So these are all equal. So write a similarity statement and find the scale factor. So we're going to say triangle RST is similar to triangle, now we're going to match them up, so it would be NQP, and our scale factor is going to be whatever this one is, triangle RST, so that's our 10 over our triangle NQP, 12.5, which we know was 0.8. Right? Example 4, determine whether the polygons are similar. If so, write a similarity statement. Okay, so 36 and 62. Well, that means this is 62, and we could find this real quick, right? We could do 62 plus 62 equals 124, and then do 180 minus 124, and that's going to give us 56. Well, our first rule was that the angles had to be congruent, and then if they are, the sides have to be proportional. However, 56 and 36 are not congruent, so these two polygons are not similar. All right, we're going to save these two examples for class. Go ahead and make sure that you've got everything done and you're ready to work tomorrow. Have a good night.